Hello, everyone. Welcome to my talk. So this talk, I will talk about the VNF framework, which we are working on, and it will be in CloudStack 4.23. So short introduction of myself. My name is Wei. I'm a CloudStack community member from 2012 and committer since 2013 and the PMC since 2017. Now I'm working as a senior software architect in JetBlue. You can reach me on via email or send a message on GitHub. You can also find me in the mailing list. Okay. So I will start with a very quick recapping of the VNF integration, which we introduced in CloudStack 4.19, and then explain why we need a VNF framework and what are the challenges. And I will give you some quick look of the VNF framework and end of some introductions and some conclusions. And yeah, if you have some questions, some suggestions, you can shout. Yeah. Okay. So what is VNF? I think many of you might already know. So VNF is virtualized network functions. It has two keywords. First keyword is virtualized. So virtualized means it's plans running in VM instances. And network functions means it provides network features, for example, static net, source net, firewalls, and DHCP, DNS, etc. You can get the VNF template from several sources, for example, cloud providers, vendors, and even you can build your own VNF template. I have a blog on the JetBlue website, which explains the steps how to build your PFSense template, which can be used in CloudStack. In CloudStack, we have a native solution of VNF, which is Virtual Router, in short, VR. So in my point of view, it's amazing. Probably some of you have a different opinion, but just in my opinion, it's amazing. It provides several network features. For example, source net, stick net, firewalls, port forwarding, load balancer, size VPN, remote access VPN, DNS, DHCP, user date, password, IPv6, and in last year in CloudStack 4.22, we have also introduced the dynamic routing. But of course, we have to be honest and to see there are some limitations with the CloudStack VR. For example, we use some specific softwares. We use IP tables. Some user might ask for some alternatives, for example, NF tables or some else. And we use edge proxy. We do not support Nginx, so we do not provide many options to customize the VR. And we also interconnect some features, for example, OpenVPN, which many users ask for. In the past conference, we have discussed the CloudStack VR several times, and so even 2 years ago. So in CloudStack 4.22, we have introduced a new feature, which is support user data for system VMs, which user can customize the system VMs and also the virtual routers. So if you are interested, you can have a look. There are also some discussion on the VNF in the past conferences by Alex. And 2 years ago, I gave a talk about the VNF integration in CloudStack 4.19. At that time, I said that that was just the first stage of the VNF support in in CloudStack. So this talk, I will introduce our new stage of the VNF support. So this is what we have introduced in 4.19. We support a new template type, which is VNF. And for VNF, user can define the NICs and also add some details to access the VNF. And when deploy the VNF, it can specify the mapping of the NICs. Yeah, and also have the option to automatically configure the firewall rules, network rules for the management interface, so user can access the VNF appliance. This is a screenshot. So it's the access information are displayed on the web UI. Some use cases about VNF. The first one is it can be used as alternative of the VR. I think there are already some users do it. In this diagram, it shows how the multi-tier application is is built with the CloudStack VPC. So we have a VPC VR as a gateway of the tiers, and we can use the VNF, for example, PFSense, to replace the VPC VR. So it can collect the MED network and some L2 networks with the VNF. Some user has asked me if we have to put the VNF on isolated networks. So the answer is no. And if you want to access the internet, you can put the VNF on isolated networks or on shared networks. So you have two options. And there are some popular root OS, which I listed here. And it provides different options. So you can have a look if you are interested. A lot of use cases we can use VNF to create a network service with multiple VNFs. So for example, we use VNF, one VNF for IDS, another VNF for firewall, and third VNF with load balancer. So this is useful. Yeah. My colleague Alex will give a talk tomorrow about the building complex scalable networks in CloudStack, which includes some usage of VNF. If you are interested, please come join. So let's go to the second section, why we need the VNF framework. So when the VNF appliance is created, we need to access the VNF and configure it. For VR, it's fully managed by CloudStack, so user do not need to log into the VR and do some manually configurations, but VNF a lot. So they have to open the web UI or access into the VNF and run some commands or click some icons. So this is the goal of VNF framework is we want to the configuration on VNF from alcohol to strategy. So I will explain in the first in the following aspects. And we target to support it in CloudStack 4.23. It's probably in the first half, in the first half of next year. So first one, we want to support pluggable architecture. So most of you know that for now, if we want to develop a plugin, we need to write a lot of Java source code, implement some Java methods, which require a very deep understanding on Java and on CloudStack. it's not easy for new vendors, and also it's not easy to manage to maintain the plugin. So in the new framework, we want the framework to be designed as extensible. So what CloudStack does is it will create an interface, and it handles the orchestration, and all the providers will handle the VNF specific logic. For the lifecycle management, we need to for now CloudStack deploys the VNF plans, but everything after that is a black box to CloudStack. So there's no way to configure the VNF appliance like CloudStack VR in CloudStack. So for now, it requires a manual intervention of the operators. And with the framework, we want to support both not only the orchestration but also the VNF configuration. We also want to support declarative configuration. For now, the problem is that the VNF configuration relies on the initial configuration, which mostly the operator sets when they build the VNF template, and also there's no health check. So we want to support a very complex bootstrap. So CloudStack can establish the communication between the CloudStack management server and also the VNF appliance. And also we want to introduce the health check. Yeah. Well, since I have showed there are several popular router OSs which can be used as the VNF appliance, and each VNF compliance have different services and also different operations, different access methods. Some use command line, some use API, and response are also different. So we want to support self-signed services and operations, and also we support multiple data models. So it's much easier. It will be much easier for operators to support different VNF. Okay. So this is our goal from the 4 aspects. So we want to the management to be predictable, reliable, and want to the actions and the services can be configurable. Yeah, and so it will be very friendly to operators. This is so our solution is we will introduce a declarative YAML-driven provider engine. So it will be a very intelligent engine which operator just need to register the VNF provider just to upload the YAML file, and the CloudStack will do everything else. So it'll pass the YAML file and support a lot of YAML dictionaries. So this is the workflow. This is the first operator need to define the VNF provider in YAML and register the provider in CloudStack, and the CloudStack will user can register the template with the provider and deploy VNF plans, which are already supported in CloudStack. And next one is CloudStack will wait until the VNF plans is ready and operational. So this is something new, and then after that, the user can perform some actions on the VNF appliance. So they do not need to SSH or into the VNF appliance or open the web UI. Everything can be done in CloudStack UI or by CloudStack API. And CloudStack can also handle the response or results of the actions, and if needed, can perform some callbacks. Next, a very quick look at the feature. So in the left panel, we will introduce a new section, is VNF provider. So on the right, it will list all the supported providers, and the operator can register a VNF provider by clicking the icon, and then it's simple. It just put the YAML file in the dialog, and then click OK, and this new provider is ready for use. So for the VNF plans, if it has specified the VNF provider, and then a new action will be added on the UI. So it's a VNF configuration, and on the top, it lists all the supported services and supported actions. So user can choose the service and the operation, and then based on the YAML file, the YAML dictionary, and it's on the UI, it will ask the user to for some input. So all this can be defined in the YAML. So CloudStack doesn't manage it. So when submit, so there's a response of the VNF operation. So this is an example of the creation of the firewall. And to list the firewall rules, it can also be listed on the UI. So all of this, the operation, the services, the operations, the input date, and the response, all are defined in YAML. So it's very flexible. So there are some challenges and considerations in the VNF framework. So we need to consider in the development. So the first one is the collection and access to the VNF compliance VNF appliance is complex. For some VNF plans, it can be accessible directly accessible from the main server, so that's easy. But in some cases, the VNF is not directly accessible from the main server. Then the things become complex. For example, what if the VNF appliance is running on IC network, or the main server cannot access the public IP? Then we need something to support it. Yeah. So we have provided two options. The first option is easy, and the main server just directly connects to the VNF directly if the VNF appliance can have an external IP. And if not, then we need something in the middle between main server and the VNF appliance. So it can be SSH and jump host. It can be HTTP proxy, or VM, or VR if possible, or external or internal server, which can reach both main server and VNF. So the second consideration or second challenge is CloudStack need to configure the VNF, but the VNF need to be configured to be reachable from the main server. So it's we call it a chicken and egg problem. So we need to, and also there's no defined. We need to define the initial actions, and also to deal with the dependencies of the services. So we support the multi-stage bootstrap process. Sorry. So when CloudStack, when user deploy VNF appliance in CloudStack, we support the user date thanks to the user data provider. In CloudStack, the VNF, we can save the user data in CloudStack VR or in config drive. So when VNF appliance starts, it can load the user data by some share script, or by Cloud Init, and then do some automatic configuration, and then CloudStack will run health check and wait until the VNF is ready, and then the following services and operations are supported. The next problem is that CloudStack sends the configuration request, but they also need to handle the response and the result of the actions. Response can be in different formats, so we need to handle it, and also we need to handle the success and also the failures. So this is our workflow, or process to handle the response. So in the YAML file, the operator can define the format of the response, and also define the transform process, which will map the response to some unified format. And also, operator can define the callbacks. So CloudStack will automatically perform some callbacks when the operation is done. Now I will give an example of the VNF provider dictionary in YAML. So basically, it will contain 4 parts. The first one is general information. And then the second one is collections. So it defines the access information to the VNF. And next one is the health check, and followed by bootstrap process. And the last one, and the important one, is services. So this is a sample, the name, general information, collection, health check, bootstrap, and service. And it can be put into a single YAML file, or we can put into different file and then create a unit file, create a file which includes all the other YAML files. In collection part, so in this example, it defines the SS collection. It can be the method, the port, and also we have a section which is the broker. So user can define the broker of the VNF appliance. Health check, it can be in multiple phases. The basic collection or basic network collection, API, and functional is check. The bootstrap, so some initial collections, initial actions. For example, if a user want to reset the user password at the first boot, then you can define it in the, you can add it in the bootstrap part. Yeah. This is a sample of the services. So we will support, the first part is the input. So this is the input which user can specify in CloudStack API, and the following are some supported actions. Yeah. Create, delete, update, list the firewalls. So this is for the date. So this is the example, and this is example of the create action. So we can get the data from the CloudStack API input, and also we can get some data from CloudStack. Yeah. Response part, it defines the format and the transformer and the callbacks. For example, if we reset the password, we can send the CloudStack API to save the password in CloudStack database. So in the next collections, it will use the new password. Yeah. Okay. So just a quick summary, and so in this one, VNF framework will introduce a declarative YAML-driven provider, so which supports the VNF configuration, the health check, the bootstrap steps, and the services, operations. So actually, this framework can be used to configure everything on the internet. So we call it configuration as code. So it's user just need to write this configuration and use it to manage every device on the internet. For example, this is the YAML file to manage a Cisco router, yeah, so the same, very similar. So collections, health check, so some services for interfaces, for routing, for ACL, or for BGP, for monitoring, yeah, etc. Yeah. So this is not just the ideas. We are actively working on it. We aim to merge it into CloudStack for the 23. If you have any ideas, just let me know. So your ideas might be implemented and brought into our next release. Later today, my colleague Harry and Marco will introduce the extension framework in CloudStack. In another room, so it's 3:30 in another room. And some of you might ask, what's the difference between extension framework and the VNF framework? So for extension framework, it's mostly used to orchestrate the resources, for example, VM instance or bare metal servers. And in the future, it can be extended to support the volumes, the virtual networks. And so in summary, extension framework allow user to orchestrate resources. And for VNF framework, we can use it to manage Proxmox, to self-monitor, and SDN controller. So in summary, this framework allow user to configure everything. Yeah. So that's it. Any advice, any suggestions, welcome.